So in last class we have seen the first derivative test. So using the first derivative f dash of x, so we will figure out, so in first derivative test we have obtained when do we have a relative maximum and relative minimum. First derivative ഉപയോഗിച്ചിട്ടുള്ള test ആണ് first derivative test. Now in second derivative test we will use the second derivative of the function to identify whether a function has a relative maximum, minimum, or neither of it at a given critical point. So this test is also based on a geometrical observation. So if you have a curve like this, a curve എടുക്കുക. So ഈ curve എടുത്തു കഴിയുമ്പോൾ there is a peak point. So here you have a peak point and here you have a lower peak. So this corresponds to a relative maximum and this point corresponds to a relative minimum. So when you take the tangent at this points, so the tangent will be parallel to the x-axis, so you will have horizontal tangent lines at this point. അപ്പോൾ relative maximum ആണ് ഇവിടെ, relative minimum ആണ് കിട്ടുന്നത്. Now you can see that this portion of the curve, relative maximum വരുന്ന portionൽ, so your function will be concave down here. So here the function is concave down. So therefore if say this is the point A, അങ്ങനെയാണെങ്കിൽ ഈ പോയിന്റിൽ f double dash of A will be negative since the function is concave down. ഇനി if you look at this portion, ഇപ്പോൾ ഈ പോർഷൻ എന്ന് പറയുന്നത് concave up ആണ്. So if this is the point B, then for this point here the function is concave up. Now when the function is concave up, the second derivative will be positive. അപ്പം f double dash of B will be greater than 0. So from this observation we will get the second derivative test. അപ്പോൾ when you have a relative maximum, the function will be concave down. So if x equal to A is a relative maximum, then f double dash of A will be less than 0, and if x equal to B it's a relative minimum, then in that case function will be concave up, so f double dash of B will be greater than 0. So this is the geometrical idea from which you obtain the second derivative test. So let us write the definition of second derivative test. So that is as a theorem. So second derivative test. So we will see how to prove this second derivative test. So the proof actually uses the first derivative test in it. For first derivative test നമ്മൾ relative maximum, relative minimum എപ്പോഴാണ് വരുന്നത് നമ്മൾ കണ്ടു. So using that we will prove the second derivative test. So suppose, so the theorem states that suppose that f is twice differentiable at the point x0, then if f dash of x0 is equal to 0, so that means a stationary point, and f double dash of x0 is greater than 0, then f has a relative minimum at x0, and if f dash of x0 equal to 0 and f double dash of x0 is less than 0, then f has a relative maximum at x0. And the third part is, so this is when f double dash of x is greater than 0 and less than 0. So if f dash of x naught is equal to 0 and f double dash of x naught is equal to 0, then the second derivative test is inconclusive. So then the test is inconclusive. So that means, so that is f may have, so f can have a relative maximum, relative minimum, or neither at x naught. That is, f may have a relative maximum, minimum, or neither at x.